Welcome. My name is Peter Hegedus and I'm from the University of Szeged, Hungary. I would like to present you a joint work with Gabor and Martin about exploring the security awareness of the Python and JavaScript open source communities. This work has been done for the MSR Mining Challenge track. So our dataset was the Software Heritage Graph dataset, which is a very large dataset containing the development history of publicly available software systems. We focused on the security aspect of Python and JavaScript programs, which are two of the most popular scripting languages nowadays. And we investigated two research questions. First, what are typical security vulnerability types in the JavaScript and Python programs, and how do they relate to each other? And how quickly the JavaScript and Python open source communities mitigate those newly published security vulnerabilities. Our approach was seemingly very simple. First, we loaded the dataset, the entire Software Heritage dataset, which was a challenge in itself because of its enormous size. But after that, we filtered the data using SQL scripts and kept only the JavaScript and Python related commit data. Then we applied some heuristics-based filtering using Python scripts to find those commits that might indicate some vulnerability mitigation fixes, vulnerability mitigations, like mentions of the security or vulnerability fix in the commit messages, or CV IDs or CWE IDs or similar. Then we downloaded the CVE data itself and mapped together those two data sources and created our final dataset, which contained more than 6,000 vulnerability mitigation commits, more than 3,000 for JavaScript and almost 3,000 for Python. And as you can see, the number of these vulnerability mitigation commits increase over time, which is not so surprising because the entire code base, size of the entire code base increases. But if you take a look of the vulnerability mitigation commits per 100K commits, you can see the ratio is increasing as well. So the amount of security fixes increases. Okay, to answer our first research questions, we analyzed the 8 most prevalent security vulnerability groups. And as you can see, except for maybe CWE 200, most of the vulnerabilities appear either in JavaScript or in Python within a category, which means that there are some specific issues that are more specific to one language than the other. For example, information exposure, resource management, improper restriction of operations is more typical to Python, while typically the web-based vulnerabilities like cross-site scripting, path traversal was found majorly in JavaScript. About the second research question, we found that none of the communities react too fast to security vulnerabilities. On average, 100 days, at least 100 days elapses between the security issue is announced and the fix appears in the code base. Okay, we further analyzed the 8 most prevalent CWE categories and found out that the Python community reacts a little bit faster than the JavaScript community, but there is some specific types of vulnerabilities. For example, the information exposure in JavaScript community, where the fix takes only a month, so they react to this type of issue quickly. But in overall, the mitigation time decreases, so security issues are gaining attention, which is a very positive thing. Okay, the very same can be seen in these charts. And to wrap up my short presentation, I can say that we analyzed the Software Heritage Graph dataset and found that there are some specific vulnerability types for Python, and they are those that's specific to JavaScript. But the time needed to fix the vulnerability is decreasing, which is a very positive thing. And that was it. Thank you for watching, and goodbye.